Cloud storage for Firebase is a fast and affordable way to store a user's files in the cloud. Let's walk through how to configure it for your web app. We will build a personal file storage web app similar to Google Drive or Dropbox. Users can upload, download, and delete files that get stored in cloud storage. The features suggested by the AI looked almost fine, but I'll strip out the AI extras. I'm also adding a line to the prompt to make sure all the functionality is simple without any fancy stuff. An earlier version of the app had some strange dialog boxes, so this time I'm making it clear that I want to keep the app simple. So the app is built and it's time for a quick test. Uploading looks like it's working. Downloading works too, as does deleting the file. Now let's try refreshing the page. The file is gone. We should ask the AI, where are the files stored? It tells us the files are stored in the browser's memory, so they will be lost if you refresh. It looks like we need persistent cloud storage. Let's ask the AI to add the Firebase backend configuration first, and make sure to mention that the configuration variables need to be defined in a .env file. Even though the Firebase API key isn't strictly sensitive, it's good practice to save it in the .env file. You should always do this if you plan to publish your codebase publicly on GitHub. The app is ready. We just see a loading animation, which is probably because it can't get the files from cloud storage yet. Now, there's a button at the top of the screen that takes us to the Firebase console and the application's backend. If we go to Project Settings, we can see the backend configuration variables. The default storage bucket name is also there. Let's look at the storage configuration. Here's the reason our cloud storage isn't working yet. To set up the storage, you need to upgrade your project's billing plan to pay-as-you-go. I'll just link my existing billing account to the Firebase project. The pricing at the moment gives 5 GB for free. After that, it's about 2 to 3 cents per gigabyte. Now let's start configuring the storage. First, you need to choose the location. There are 3 no-cost locations in the United States, or you can browse the All Locations drop-down menu if you are located somewhere else. I'll choose the US East location. Next, there are 2 modes you can select: production mode and test mode. Production mode means your data is private. In test mode, your data is public, which means anyone can view, edit, and delete all of your data in the storage bucket. After 30 days, you must update your rules, or no one will have access to the files. I'll choose production mode to show how it's done in a real setup. The bucket is ready. Here is the folder path to the bucket, and it looks like it is the same as the default bucket. Yes, it is the same. In case you need to use a different bucket, you can just change the value here in the .env file. Time to test. We still have an error. Something went wrong. The message says, "User does not have permission to access files." It sounds like the request found the right bucket, but because we configured production mode, it is blocked by default. Let's head back to the rules and allow all traffic. We just need to change this false to true. We get a warning that anyone can steal, modify, or delete data. This is fine for a quick test, but you should never leave the configuration like this. Now let's refresh. We don't get any errors this time, so let's upload a file. It was successful, so let's go to the backend to see if it received the file we uploaded. Yes, it did. Let's also try downloading. It works, and then we test deleting. It also works. Excellent. We have configured cloud storage, and it works, but this probably isn't a final plan for anyone to have public storage when they are paying for it. Let's move on and set up a personal storage for each authenticated user. First, I'll set up Google Authentication for the users. If you need more detailed instructions about authentication in Firebase, I have another video about it, so just browse my channel. Then we need a sign-in button in our web app. It doesn't work because our test domain needs to be added to the authorized domains in the backend. All of this is better explained in the other video, so I'll do this very quickly without explanations. Let's refresh the page and see if I can sign in. Yes, it works, and we can try to upload something to the storage. That works too, but let's double-check the backend. There is a folder called Files, and inside that folder is another folder with a name that looks like a user ID. Finally, the file I uploaded is there. It looks like the storage based on the user works, but remember, we still have security rules that allow anyone to access the files. Let's find suitable security rules from the documentation. There is a lot of useful information here, but I know from previous projects that we can find what we are looking for on the page called Basic Security Rules. Note that there are rules for Firestore, the real-time database, and cloud storage. Be sure to select the Cloud Storage tab, or you may be copying the wrong rules. Here is an example for authentication, but this one lets anyone access who is signed in. We don't want that. We want a specific user. Here is an example for the content owner only. That is what we need. The rule says that the file request must be authenticated and the UID must be the user's ID. Let's copy that code snippet. An important thing when copying the rule to your setup is to remember to leave the line rules version equals 2. If you accidentally remove that line, it currently leads to a bad HTTP request or another unknown error. I'll make a couple of changes to the rule. I'll add the delete method because we will need that for deleting. Also, remember that the folder where we store the files in storage is called Files and not User, so I'll change that too. We're ready. Publish changes can take up to a minute to propagate. It's ready. Let's give it a first test. Everything looks like it is working, but to do a final test, we need 2 Google accounts. Since this Firebase Studio test environment is only accessible to my personal development account, I'll publish the app and then do the final test. It's published. Once again, the sign-in doesn't work, and the reason is the same as earlier. I need to add the web address to the authorized domains. Now it works. I'll upload something to my first account. Then I'll add another browser window and we can upload something there too. It works. Both users have their own files stored. If we double-check the backend, we can see there are now 2 separate folders with the user IDs, and then in those folders are the files of those users. If you are having problems with your setup, I can give you some really good advice. Search for an example piece of code like this one about uploading files with cloud storage. Even if you are a no-coder, try to read through a little bit of what's in the example. It creates a root reference and then defines the file. The actual operation is then later with the upload bytes method. Then, go to your code view and review what the AI has done there. You'll find the same lines of code with slightly different values. Here's the root reference. If you click search and type upload bytes, you'll find the upload method. You will also find, for example, the folder where the AI tries to write the files, and then you can double-check if it is the correct path. Just learn to read the code a bit. and you will find that there is no bug in the world that human eyes can't fix if given enough time and resilience. That wraps up this tutorial. If you liked it, please share it with your fellow coders. Happy coding!